why don't we kick things off? First of all, thank you everyone for coming. They told me, I think a couple weeks ago, I had like 8 people registered, and I was like, oh, all right, well, we'll see how this goes. But it's great to see you all here. Hopefully, it's the 3rd day of the conference. We're getting towards the end, but I'm going to try and pull you all through. I'm going to get all the energy. I'm a little tired. Maybe there's some people in the room that are part of that problem. You may see them laughing. I'm not going to name any names. Some people kept me up late last night. They were trying to sabotage this workshop, but I didn't let it happen. Okay. So the first thing is, I just want to give a quick introduction. So I am a developer advocate at Apollo. I lead DevRel there. And I've been working with GraphQL since about 2018. And really, I just am obsessed with making GraphQL APIs. Very specifically, I'm very passionate about schema design. And I'm really excited to talk with you all about this. And I really want to make this interactive. I was going to ask some questions to the room that we may not have time to get as interactive as I hope, because there's so many people, but we'll still get into it. So I was actually planning on having everyone in the room introduce themselves. And now that I see everyone here, there's probably too many people for that. But what I do want to ask the room is I really want to make sure that this session, this workshop, is really connecting with what y'all are doing. So I have a couple different exercises, content, things prepared. But I wanted to ask the room, is there anything specifically, schema design, that you were hoping to walk away from today with? Or maybe there's a question you have, thing that you're hoping to get answered. It could be specific about your schema. It could be something general. Is there anything, any brave soul that maybe wants to say of hoping you're to want to accomplish here? Yeah.
I want to know the common mistakes people tend to make while they're creating schemas. What's the recommendation as a standard best practices?
Yeah. So I'll repeat that. So best practices, but really, what are the common mistakes people make, and how to avoid those? For sure, definitely.
I have something specific, but probably not general enough. I find it difficult to design schemas that is hard to have an idea, like a time series graph. Like you can retrieve the entity on any history of the time, and also traverse the graph on any history of the time. Where most GraphQL relies on the ID to do the fetch or federation, it's a little bit hard to design those kind of.
Yeah. OK, time-based graph. That's an interesting one. Yeah, maybe we'll have some time to do a little bit of stuff around there. Common mistakes. All right. Yes.
In my company, we have a challenge regarding error handling. So I have a question regarding error handling for things like metadata related. For example, error code. Are those things should be part of the schema itself, or should we use a GraphQL extension or other techniques?
Yeah. Great question. Anyone else? Yeah.
I guess a couple questions. One is, what if I ask for something and I need to redirect it to another place, another resource?
Mm-hmm.
The second one is, if I'm requesting, let's say, 2 lists of things from different subgraphs, how would I redo the common things? Is that a schema design thing? Is that a data resolver thing?
Yeah. And so in those 2 lists, are there common objects between the 2?
Yes.
Right. Kind of like a recommended products, suggested products, and there's like some overlap. Yeah. OK. It's OK. And if you have more questions or anything as we're going along, we're going to do some friendly exercises and kind of get into it. But I got these list of questions, and my goal is by the end of this, we either hit all these, or if we don't have enough time, I'm going to be around afterwards. We can talk and still get into it. OK, so how many people have GraphQL in production today? All right, I love seeing that. That's like almost everyone in the room. That's a lot. How many people are running a single GraphQL server, monolithic GraphQL server in production? OK, about half the room. How many people are running multiple GraphQL servers, doing some sort of stitching, federation? OK, so we got a split about 50-50. I'll definitely hit on both sides of that fence, but I wanted to see where where we are at on the split inside of there. Okay, so the very first thing about demand-driven schema design, and I think the first theme, common mistakes. One of the common mistakes people make is they don't design their schemas based on their clients. One of the common things I see a lot of teams do is they spend months and months and months of trying to design their schema and put something out there. And really, you want to get that first iteration and start iterating on that from there. And it's really important to make quick decisions in that because you can lose a lot of the magic of GraphQL, and there's also a lot of things you have to learn as you're getting into production. And a lot of you already are there, so you've kind of already seen that. So the first thing we're going to do is we're going to do a little exercise. So everyone's got a Post-it note. If you don't have a Post-it note, raise your hand, I'll come get you one. What we're going to do is we're going to write an ideal query. So schema design, schema governance, one of the common ways I see a lot of teams of how they're building and designing is they start out with some UI that's coming from a product designer, right? And this is what I mean when you're talking about designing your schema. It really starts out at the client's needs, right? We're using a website in this situation. There's chatbots out there. There's voice. There's all these different types of clients, right? Think about application development. We're just building an application. We need some operation for that to fulfill that. You really should be trying to make that representation what the client's needs are. Don't worry about what the data is stored or how it is. So we're going to take the next 3 minutes. Everyone's got a Post-it note. You're going to write down what is your ideal query on the Post-it note. Take your time to think about it. Just a little background. This is from GraphOS. This is just a list of graphs. They have a variant name. It's a table with last published types, things in there. Feel free to use whatever names you want, and everything's okay. Nothing's wrong here. What would you want this query to look like if you were the client developer creating this UI? All right. And I'll come around and give Post-it notes to those who don't have it. We'll go ahead and start. Yeah, no problem. All right, we got about 1 more minute. Okay, all right. So what we all just kind of walked through is just a little warm-up exercise for us, but really this is the starting point of a schema design process, right? We took some time to think about, all right, we need to create this UI thing. What do we really want, right? And well, like if I'm the web developer, I'm thinking about like, what do I want my React component to look like? What do I want that query shape to look like? What's going to make it easy for me to do that? You know, and a big part of when you start thinking about that, think about progressive loading on your website, right? Or some interaction you're trying to have there. This is where the shape of that operation starts to become a little important, right? You can definitely have a response that comes back that makes it a little more difficult for how you're doing your kind of suspense handling of your components and the data, depending on how it's all kind of coming back. There's definitely a lot of tools with things like defer that are coming along that make that much nicer, but thinking about the client use case at the starting point is important. So now we're just going to take 2 more minutes, and I'd like, since we all have good tables, if you'd like, you could move over. I'd like you all to discuss your table now. And now you have a bigger pads there, and I'd like each table to agree on one shape, right? And then we're going to talk about some of our shapes. So each table, you have to agree on one shape and get it on a piece of paper, and I'm going to come collect it. And I said 2, in 3 minutes, okay? So let's begin the next part. Go ahead and start discussing your operations and come to an agreement. Yeah. Oh, whoops. I was actually just getting my thing ready for the next part. Yeah, let me put that back up. Look at that interaction. All right, we got 1 more minute. If you haven't started writing, start writing down on your single piece of paper. All right, I'm going to start collecting. Okay, let's start having your piece of paper written down. I'm going to start walking around, putting the pressure on. It's hard. You got to make a decision. I love it. Decision made.
We don't know what
We only have one person in the room.
That's okay. Hey, this is the reality, and this is why we're doing this exercise. It's important that we all go through this part of the process because we all end up getting deadlines from our bosses, right? And this is the reality. All right, so which is the piece of paper? Which one are we submitting? Okay, all right, I'll give you one more second. We're late on our first PR. All right, which one are we delivering?
I think this one will be changed from user to theme variants. Do you want to go one deep?
Okay, it's okay. It's okay. I'll come back. We got our submission here. Oh, excellent job. Excellent job. Okay, let me write your table number down. You're 4.
I don't want to fetch all 458 fields.
Okay.
Get the count.
Okay.
To be stored somehow.
Is this the submission? I don't want to punish your whole table. I want to take it right now from you, but I don't want to punish your other teammates. Is this ready for submission? It's okay. I promise it's going to be great. Excellent job. Excellent job. All right, table 3. Okay. Okay. We're almost there. Okay, it's okay.
Sorry, there's one other.
This is such a good exercise.
One question. Designing a service, not client application. We are on a mission just to, we do not only know all the use cases for the queries.
We're going to get to that next. That's the next part. Yeah? See? And this is where we'll talk about that part. What's important is this part ends up becoming part of the process no matter what. Because once you get to that first version, then it becomes important that all your decisions you make after that, because you don't want to put things on your graph that aren't going to be used. You don't want to get in the habit of being like, well, let's just put this thing on the graph because like people may want to use it or probably. Because then you start getting to the point where your graph gets large and you get things that aren't being used, and then you have to prune them off. Yeah. But even in like opening up all that data, there's already current things that are consuming that data, right? There's already some known consumption. Maybe not like in how you have purview into it right now. Yeah. Yeah, and that's what we'll talk about. Now we'll be talking about the scope of REST, but we'll get into that in a sec. Okay, now I'm going to just go around and start collecting. Our website's got to ship this feature. And if we don't ship, we're going bankrupt and we're out of business. I think that looks great.
Thanks.
That looks great. No, don't worry about it. See? I'm a good manager. Everyone's getting promotions. All right.
Like if it belongs to Moonshot or belongs to what is name? For the super graph.
Go. Thank you for just holding it up. Your table 2. Okay. No, I did a numbering on my side. Okay. I like it. All right. And then do you have yours right here? Yeah, that's totally fine. Okay, cool. All right, so we got all of our submissions and everything in. So let's talk a little bit about this UI. Now, the first thing I want to say is, what did we all get to experience right there? You were all new devs, started a company on a project that you had zero clue about. You have zero clue of the shape of the graph. You have zero knowledge of all these things. This is the reality of a new developer starting with their first feature at your company and using your graph, right? And they're trying to contribute in here. These exercises are really just meant to convey that to you. Doesn't matter what state you are in your GraphQL journey. This is the reality for new people coming onto your graph, right? So when we're thinking about schema design, it's of course, yes, the design of our schema, but it's also the process of going through this. And that coordination of even the discussion you had to have at your table. That's the real world of what you have to do when you're talking about designing schema changes to your graph. So I'm just going to look through a couple of these. You know, I have at the top level, it looks like there's a pretty common theme of having favorite graphs, favorite variants. I have graphs, names, all very interesting. Now, one thing that I'd also like to bring into the context of this, when I think about schema design, I like this concept, what I think of almost as like name spacing. And what I really like to do is I like to put together groups of functionality into my schema. And we'll actually look at some schema files and stuff in a second. But inside of this scenario, they are favorite graphs, the favorite variants, whatever you may want to call them. But what are they associated with? A user at that top level. Most applications, most graphs that you have, it's very common to design a me entry point because it's me. I'm the authenticated user. One of the things we'll touch a little bit on later is, you know, designing your schema also for scenarios like AI. It's very helpful for AI to understand what is the actual entry point for an authenticated user on your graph. There might be multiple points. You know, it kind of depends on how you design that. But that's actually just one thing that I want to point out inside of the operations when I kind of skim through what people's submissions were. There's the user in that context, right? Now, let's, well, I was supposed to click through that. Let's go to the next portion of this exercise. Now, we're going to spend 5 minutes talking about this, so we're going to go to the other side of the house. So I actually got a question from the back of the room, which was about, okay, well, like that's great about these client scenario, but there's a lot of people that come into the development of, we're the back-end team now, and we don't necessarily know all these client scenarios. Maybe there's GraphQL that started to bubble at your company, and now you're a platform team that has to support a GraphQL API, and you traditionally have supported a bunch of REST APIs or something like that. So we have a little bit of shape right here. Got some reviews, some metrics. We're just going to take 5 minutes. In our tables, we can discuss this and talk about this. Some of you might already have this. This doesn't need to be a federated schema. This is just a single schema we're going to talk about here. But I think some of the relationships that are inside of here are important. So let's imagine that we're back-end developers. And we're going to take a moment to discuss between ourselves of how we might design some of these schema points into our schema, or some of these REST API points into our schema. And I'll be floating around the room if you have any questions or want to chat about it or anything like that. You can feel free to write notes on your paper, but don't worry, I'm not going to parse your GraphQL schema. You don't need to, you know, be spec compliant there. Cool. All right, let's begin. Yeah.
Hey, I'm going to ask a request if it would decline since you're
Yeah.
sizing other people. So I just
Yeah.
came in late. So you want to catch me up in like 30 seconds? What happened in the first 15 minutes?
Yes, yes. So in the first 15 minutes, we basically designed out an ideal operation based off of a UI that was on a screen. And then we just talked as groups to collaborate on what's an agreed upon shape. And that's kind of the starting point for most schema design processes within companies and projects is what's the ideal shape we need for this React component, this iOS app, this chatbot, whatever that may be. And then coming to agreement of like, okay, what's that shape? And then now we go to the next part of this design process. So now we're kind of flipping over to the other side of the fence, and we're taking on the role of a back-end developer that's creating a new graph based off of existing REST APIs in here.
Okay, these are 3 REST endpoints? In the
Yeah,
single
3
API?
REST API endpoints, and we're just going to make a little schema based off of that. So we're just kind of discussing that and making some decisions. So you'll probably have like a review type, right?
GraphQL schema or DB schema?
What's up?
The schema. Like, what does that mean?
GraphQL schema.
GraphQL schema?
Yeah.
Oh yeah. Sorry, I should have put that. It's because these guys kept me up really late last night, and I forgot to put the GraphQL schema. Yeah. Yes.
For metrics reviews, what is the ID you're passing in there?
That's a good question, right? So that's going to be the review ID. It's going to be the ID of the review that's inside of there.
But then how could there be a review count more than one?
How could there be a review count more than one?
If you're specifying the review ID.
So it's like identifying
Yeah.
the review that the metric is from.
Yeah, so that review is like the review that's like on there. The review count could be like likes on the review. Yeah, how people find this helpful? Yeah. It's not, now, is it a good naming for it? No, but that's kind of the reality of that. But that's meant to be
Is the average?
average, average rating is like the average rating of the review. This is where like, and there's a lot of scenarios. I've actually had people where they talk about scenarios of like, yeah, there are people that like review. If you think of like Steam and like how like a lot of the review system, there are people that interact with the reviews, have comments, and it starts to become a world where you're like, wait, why would you let people do that? And I agree.
Can you clarify again how track ID is track ID? What does that mean of that? Track ID.
Yeah,
Not really clear what that means.
it's just a random other track ID, just an ID for another thing. So there's probably like a track, and there's probably a track API endpoint somewhere.
Track API endpoint.
Yeah. So like when you think about in the JSON object you get back from a REST API endpoint, there's a lot of thing_ID or thing ID. This is just another one of those thing IDs. It doesn't even matter maybe for what you're building on your graph. Sometimes when you design your schema, you don't bring all of the fields along. Actually, I would make the argument when you design your schema, you should never show ID fields like that. Like if you were making a review, you wouldn't show a track ID field on your review. You would show a track object.
Track object. But
So you just don't have the full picture of the full APIs.
I guess I just don't even understand what track is.
So why would you put it on the graph? That's part of the exercise. There's a lot of times when sometimes if you're in the persona of I have a REST API and you're being told, let's put that on the graph. There's going to be times where you're going to have fields like that come from the REST API, and you should be the person that's like, that shouldn't go on the graph yet. We don't know what that is. What's the use case around it? Thinking of the client exercise we just did, if you don't know what that thing's going to be used for, don't put it on the graph. So you're asking the right questions. Don't even put it on the graph. It shouldn't be on the graph. I'm sorry. No, my bad. How y'all doing? Good.
the people who can consume metrics will consume review. Or different people. But they didn't specify that.
All right, we got about 2 more minutes. A lot of good discussion, so about 2 more minutes.
Expose the one that is going to be used because later, if you try to use it, there will be a breaking change. So I think the answer is probably we shouldn't provide schemas.
All right, why don't we wrap this up and we'll keep moving us along through here. So I want to talk about a couple things that I heard even just through conversations, and we'll actually pull up VS Code and we'll design this together. So there's sometimes you're going to be maybe in the persona of a developer that is being told, I have this thing that I need to be put onto the graph, right? Here's these REST APIs. We need to put this on the graph. So you're coming to put these on. This should have been confusing. There's a lot of times in the REST APIs you're dealing with, you might have a giant JSON object that has something like track ID. And you're like, what's track ID? What's track? I don't even know what that thing is. It probably shouldn't be on the graph, right? Thinking of the exercise we did right before this where we were thinking about the client and what their use case is of that. The purpose is you don't want to just put stuff on your graph if you're not quite sure of what its usage quite is yet. Very specifically, this like track ID. I'd also make the argument you should never just put an ID of like track on a review object, for example here. You'd want to put the track, right? And then you'd have a track type. That track type has an ID, of course, right? And this is how we start to design out our schema. So I'm sure there's probably lots of opinions of how this should be written. I'm going to pull up my VS Code. Oh, look at all these windows I have. Oh my goodness. Oh no, I have all these things that's running in the background I'm not supposed to show y'all. Well, yeah. I have like everything from my talk yesterday. Okay, let's just move this over so we have this side by side. Okay. All right, so let's just talk about designing out some of our stuff. Now, a couple things I want to show real quick. I think one of the things that's really important in schema design in general is that you figure out some way to help do that more effectively for you. What I mean by that is there's a couple different ways of how we can design our GraphQL APIs, right? We can either do an SDL first, schema-based, where we're actually writing SDL, and then we're loading it up. That's like Apollo Server does that. A lot of different servers do that. And when I give these options, it's probably a 50-50 split of what people do. The other option is code first, right? Where you're actually adding annotations into your types or your code, and then that's actually generating a GraphQL schema representation inside of there. Either way of what you have, you should have some tooling or some process where you can quickly, easily have discussions of like what we were just having with inside of schema. And I want to show you a couple tools that I use of like how I do that really quickly. And there's probably differences of what you might want to use, but I'm going to show that so we can use that as a conversation for when we're like doing some schema design stuff. So the first one is really just a very, very simple solution. And I have just this little script here on the screen. It's using Apollo Server. It's using GraphQL tools to just mock a schema file. And this just allows me then to write a schema file, run this server, and then have like a little playground environment where I could write operations, see what data comes back, everything like that. I am a TypeScript developer myself, so like this is great for me. I love this. But if you don't have Node, this is a type of experience you probably want to build with like what your server is or something like that. Another option, especially if you're in the federation world, I saw half the hands here. Rover, the CLI you would use to compose your graph together of all those APIs. There's also Rover Dev, which is a way that starts the Apollo router locally and lets you kind of point at things and you can hot reload it. So you can actually point it at just a schema file and just give it like a random URL. If we do something like that, I can just open up localhost 4000. And this is just Apollo Explorer in a sandbox mode. And in the settings, you can actually click mock responses on. So you don't even need to worry about like having anything running. It's just really about, I have a playground now where I can like make changes to a schema, check it out, and do stuff. So now we kind of have that playground experience where we can open that schema file and make changes, right? So that hello was an integer. If we change it to be that, you can see everything kind of hot reloads in the background. And then if I run that query, now it's a string, right? So this is what I mean about having that little playground experience. So in your schema governance, it's important that you have this tool so that your new developers can kind of like reason with like, how am I going to just maybe, play around with what this schema is. I'm an SDL first fan, so if you have a code first environment, this is just something you need to think about. What's that preview experience for your developers out there? I'll share the gist of the Apollo server snippet also, and the Rover docs. Okay, so let's pull up that, and let's talk about this schema real quick. So what I like to do when I think of a REST API, and this is with domains, I really think about entities. So whether you're doing federation or not, entities are in our graphs. Entities are in our business. You already have them in your APIs, your databases. It's all part of everything. And so I like to think about it like this. When I have REST APIs, it's very obvious which ones are entities when you start looking at some of the routes. So reviews, for example. A review is an entity. There's a unique identifier for the review in multiple places inside of here, right? So I immediately start identifying like that's an entity. And it's hard to say what is an entity in your graph without having some knowledge, right? How your business is orchestrated and structured is important details in there, right? So this is general knowledge, or general guidance, but it's going to be specific also to what is your use case of what you want to do inside there. So that being said, I'm going to make a review type, right? And I can see I have an ID, and then I have things like I see reviewer name. When I see things like that, how many people changed what that field's name was? How many people like snake case? How many people like camel case? How many people changed it to camel case at least, right? One of the things I start thinking about here, and I think this is really important when we're talking about designing our schema for the future, and I'm a big fan of GraphQL schemas aware for AI. Reviewer name, is that actually like what we want to have? Is it actually there's a user there? And that's not what we want to have on there. Like, what is reviewer name? Like, how would I actually show that in applications? What's actually like matters there? Do I want to let people be able to click on the name? Is this just like an anonymous name? What does that mean, right? So I might actually look at that and say, I don't know if I want to put that on there yet. So I might skip that field and say, no, you know what? We're just going to put the string on. We're going to put the rating on. And I'm looking at everything else, created on, updated, you could do that. I'm probably going to want to have those as date times, which means I'm going to have a scalar that's going to be for the date time. I'm not even going to put updated at. I mean, I guess that's probably good. But these are kind of like little decisions, doesn't matter, who knows, inside of there. Now that we kind of have this review designed out, I can see that there's two routes, right? Identifying the review by itself and getting a list of them. That's probably something that I'm going to want to expose on my root query, right? So I have a review. And reviews. Right, so pretty straightforward. Now I have this weird metrics thing on this side, and I had a lot of questions around this of like, what does that even mean? Like average rating, what's like review count? And this is like where things get really confusing. And this one's meant to be really confusing because sometimes it like doesn't make sense. Like, does this review have reviews on it? Are there like comments as part of this review? Why does the review have like a rating that's average for the review? And like, what is that review count? So we were kind of discussing the review count's actually meant to be like how many people found this review helpful type of situation, right? And sometimes like how the data is stored, what it means, like it's super confusing. And this is also one of the reasons why GraphQL is great. And you don't want to have your client developers interacting with your REST APIs because sometimes those things like, what, that doesn't make sense. And if one client team is having that issue, multiple client teams are having that issue. Right, so this is where we may just want to put like an actual like found helpful count, right? And now it's really more of like the details of our resolvers of how we're getting that information. We're kind of abstracting that away from our client developers. So that's really important there. Okay, let's jump back to our slides. But before I move on, any questions, any thoughts, anything that maybe you wanted to call out that you saw in your discussions from kind of that exercise? Yeah?
So I'm just curious, should we make everything in one schema? Should we have a separate schema to represent different domains? Like it sounds like the tracks, the metrics is different from the left side.
Yeah. So this is where, I'm obviously biased because I work for Apollo and Apollo Federation. So I want to put that little asterisk there. Yeah, I would say they probably would be separate GraphQL APIs. If you were already in a microservice architecture and you were going down that path, yes, I would create those as separate subgraphs inside of there. We're actually going to walk into another exercise with Stripe that is going to get into this very specifically. So why don't we jump directly into that? Because I think this is one of the things I like to call out and give very quick guidance, specifically in the federated architecture. So Stripe is got a lot of things in it. And Stripe is known as like great docs, everything's fantastic. And if I was building a graph based off of Stripe, because their docs are so great, it's actually very easy for me to design out what their graph should be. And when I talk about teams taking too long to design their first schema or design that first part out, I think a big part of it is because when I think about designing the schema, you could actually make about 80, 90% of your decisions with just this one recommendation pattern, right? So when you talk about common mistakes that people make, I think it's not following this pattern that really gets you into trouble. So in the back room, we were asking about how do we design a graph when we don't know our client use cases, we just have a bunch of data APIs. I think this is a great pattern to follow inside of here, right? So we have Stripe's documentation over here. We have all this navigation on the left. Ignore everything on the right. Don't even think about anything over here. It's this left side. This is where all the magic is. You see each one of these? These are your subgraphs. I got all the subgraph names for you right here. And you may make a decision, hey, Michael, great, but our checkout and billing, we want those to be together in the same subgraph. That's fine, no problem. But if you were just gonna ask, what should I do? I'd just say, well, just make each one of these a subgraph. Okay, now let's click into one of our subgraphs. Who wants to name a subgraph? Which one should we click into?
Crypto.
Oh, crypto, okay. Spicy one to click into, but let's do it. Okay. So here's crypto. All right, so it's called an on-ramp session object. But if you look at it, there's a get on-ramp sessions ID on-ramp sessions. That looked a lot like our previous exercise with the reviews and everything, right? All right, so I think we found our entity. So there's our entity. If you're talking about federation, it's got one key field, ID. Cool, you know? So this actually becomes a pattern that you can go through, and you just have to ask a couple quick questions. You know, you go each one of these down it. Should this just be its own subgraph, or should we actually add it into another one because we think, you know, we have these business SLA XXXX thing, right? Those are internal things that no one will be able to help you answer, right? You just have to have that internal knowledge, and it's going to be specific to your business, your use case, your industry. Those aspects are important into how you design your schema. But at its general level, you can answer those when you're just going down this list inside of here, right? So we're going to do an exercise into designing a little portion of Stripe's API. The use case we're going to take is we use Stripe for our checkout scenario, okay? So we keep all of our product pricing information inside of there. So we're actually going to go into the product section for this one. I'm going to keep it up on the screen. These are our endpoints. This is our product object inside of here. And there is a default price. The price is what we need, okay? So the price is what we want to put on there. Now the specific thing is the price is an ID of an object, okay? So we're going to need to design our schema, and I'm going to pull up the prices side by side for y'all so we can see the pricing object right next to the product object. Can everyone see that on the screen in the back? Is that bigger? Bigger? Yeah. Yeah, you don't need to see the posts. Just worry about the gets for now. Okay, so let's just take 3 minutes and let's just design and talk about how we'd structure the product and the price object together, specifically from that, okay? All right, so we'll get back together in 3 minutes. And I'm gonna refill coffee. How we doing? Do we want a little more time? Do we want to? Let's take 2 more minutes then. I see some still discussion going on and everything.
That's my understanding. Yeah, like I think based on the Stripe one, it is. It do have expense, but as a general concept, price doesn't have to. So, like in the Stripe one, the 2 items that are both $5 are actually 2 separate.
All right. I think we're going to bring it on together so we can move on to the next stuff. Now, what I hope this helps convey a little bit of, we went from kind of a silly example, not silly, but a little example with reviews and everything, to a very real world API, right? This is very real world. And I heard a lot of conversation even about some of the gaps of like, it just shows null there. Like, this is the reality of REST documentation. I challenge anyone to find me open API specifications that are fully complete, because almost every single one is not. So a couple things about this. Let's talk about actually designing this out a little bit together and what I might do. So the first thing I want to show is, since we talked a little about federation, I'm going to take a step deeper into that. What we can create is we can create a supergraph.yaml file. It's got a federation version. We're going to do 2. It's got subgraphs. We're going to have a products. I might get some of this wrong because I'm doing it live. We're going to do products.graphql. Price. Price was the other one. And it's not files, it's file. I was like, should I copy and paste this in front of everyone, or should I try and like write it live and hope that it works? So we're going to try. So we're going to create our products.graphql file. I'm just going to put a little hello in here just to get it working. And then we're going to create a little price.graphql file. Hello 1. So let's make this full screen, pull these up side by side. So that same rover dev command, you can actually give it a supergraph config option. Confit. It's a really, really tasty dish. Yeah, especially when you spread it on crackers and everything like that. Supergraph. Oh, I'm in a wrong directory. No routing. Oh, yeah. That's got to be in there. See, I knew there was going to be some things. There's got to be a routing URL. That's got to be just a fake value because we don't have anything. All right, let's. I did it. Yeah. All right. Cool. I did it. Yeah. I typed it all right. Yes. I have been arguing that typing that stuff right is actually hard, and we should just like give like a file new thing. But I'll get off my soapbox there. Okay. So what's cool about that is now that we have all of that running, if we go back to our localhost 4000, we got now both of those things together. And what's cool about that is we can also, it's supposed to show a query plan. I assume, oh, it's because I'm mocking the response. Just kidding. Let's turn that off, because now it'll show a query plan. So now what's cool is we can design our scheme and actually see like what that query plan is. We're going to talk in a second about that list deduplication question. I'm going to get to that, don't worry. So let's talk about this real quick. So the first thing is we're going to have a product, right? And this is where we're going to have the @ key. Now, for those of you that aren't doing federation, no problem. You don't have to do this stuff. But in federation, the @ key field, if you saw from the keynote what the composite schema working group is looking at, I believe it's @ lookup is what it is. There will be a directive that ends up getting put in the spec for like composite schemas that defines what an entity is. This is just how you do it in Apollo Federation. Since we're using Rover, that's what we're doing inside of there. So we have our product. There's a lot of things we can put in here, but more specifically, we were talking about our price, right? And that we already said was going to be its own thing. Now, there was a lot of things of like default amount, currency code, all those things, and you all have had some rich discussions around that. And to be honest, I don't have opinions of how those things should be. Those are some of the details where, it's not really a schema design recommendation. It's up to you to decide, like, should that field actually be on the graph or not? There's definitely a lot of fields from REST APIs that just like don't put them on the graph. If anyone is ever just copying all the fields from a REST API response into your graph, stop them. Like that can never happen. I've never seen that work out. It doesn't work. You pick what you want to put on there. But more importantly, what I think is important to show here is just that connection. So when I talked about in that reviews example we had before, the metrics and the review and the ID and the track ID, this is what I was talking about, right? We wouldn't put price ID on product because that doesn't make sense to the users that are actually consuming the graph, right? They just care about the price. And inside the price has things like, the amount and like the currency, which is like a 3-digit code. And all of that should just be able to pop up in here. I hope this works.
I need to retouch.
No.
Or have you exposed any of your root types on query?
No, oh, yeah. There you go. That's it, yes. Well, we tried. It wouldn't be a good demo if it didn't have some things that just didn't work, right? Like that's got to be the case. I don't know, maybe there's some error things printing out. Maybe I got something here. I don't know. We'll restart this. Oh, unknown type price. Yeah, because I didn't make a valid schema. That's why. Yeah, that's just because we just need to include that price type here. That's it. And I don't know why it's not hot reloading. I am using my own build of a Rover binary, which definitely could be part of the problem. But you do what you got to do. There we go. Products and price amount. And the main thing just to show there is about that query plan, right? And it's here. Now, what I want to talk really quickly about, just to add into here, is the deduplication. So like, let's say we actually did have something that was doing recommendations. So if you had, for example, a recommendations.graphql file, I'm going to put this one up here. Now, specifically, we have kind of everything put together. You know, we might want to start putting like, alternative, you know, and it's a list of products. You might want to have like suggested list of products, right? You might have someone that's writing a query that's now pulling in all of these things, right? And especially if you had like a list of products, and then I'm also pulling the alternative and suggested products and all of the titles, descriptions, prices, of all that. I got a lot of things that are inside of there. When you think about this federated architecture, though, all the product is defined in products.graphql. The execution that's actually going to happen, all your products, all the products from inside of those things is going to come here. Your recommendation should only be returning the ID of the product. A lot of times I'll have teams say, yeah, but our recommendations REST API thing returns all the product information to it. The concept of having a partial data object and a full data object, meaning I request a product, it returns a partial pricing object along with it. If I want the full pricing object, I have to make a second request to the price point of the API to get the full price object. This is very common. Salesforce's REST API actually works this way with how they do their S objects. Every S object returns a partial object, like a Salesforce account returns like contacts, but it's just like partial contacts. And then if you want the full contact details, like their address, you have to call into the API for that specific contact's ID. Now, when you're doing something like that, this gives you an opportunity to add a caching layer in the product subgraph. Caching that product now is going to give you the opportunity to have deduplication across a lot of these things. And more specifically, when you think about like recommendations, like suggested products is a great example. The suggested products or recommended products from like the front page of your e-commerce website is going to have some overlap across your users. Sure, you have maybe, let's say 10 things that are being recommended. The top 3 maybe are like promotional things from the company. And then the next 7 are recommendations based on the individual user. When you have a caching strategy based off of that product subgraph, the users across each other are going to benefit from cache hits on that product from those ones that are the company suggested ones, right? So adding a caching layer in your subgraph when you're actually architecting how that is can have drastic performance benefits. Because when you think about it, the product really isn't changing. You want to be able to change the price, stuff like that, pretty dynamically and everything, but the name of the product, the description, how often is that changing, right? You can at least put a 60-second cache on that, and you're going to see a very big performance improvement from that. Also gives you the ability to start doing things like CDN caching at the edge when you start thinking of what's a root level query with like persisted queries and things like that. Cool. All right, so we only got 20 minutes left. I got time-based graph. That's going to be a hard one to hit today. And then I got error handling and redirect to another resource. So we're gonna try and get to some of these. I think one of the things that is important, especially for the redirect to another resource, is talking about architecture. So we've talked a little bit about entities. We've talked a little bit about structuring our domain, structuring our graph. Talked even a little bit about subgraphs. I do want to talk a moment about some federated architecture since we've kind of drifted into that. And I think that's one of the sections we should touch on now. So very specifically, I have a lot of people ask, like, what architecture should I use for federation? And one of the things I think is really, really, really important, whether you already have a graph, you're getting started, whatever it is, you want to meet your developers where they are. I think it's always important to meet your developers where they are. If there's a certain architectural pattern that you already have internally and everything, you want to try and map to that as closely as you possibly can. Don't try and introduce a brand new, everything that's going to be completely different. For example, if your team's already doing full stack development, don't try and give them like a federated microservice architecture where they don't have any ownership in the APIs. Because they already had ownership in the APIs, and then you took that away from them. And now they're doing this new thing, and that's going to be another pain point of why they might not successfully adopt your platform or your new thing, right? So the first one I like to talk about is a full stack federated architecture. I don't think this gets talked about enough. And what it really lends to, and I think it's really important, especially with like the rise of chatbots with the resurgence of AI and LLMs, you have teams that are building essentially BFFs. And especially in like the chatbot world, you know, they have deadlines that is being pressed on them. That's kind of where I was walking around the room with like, hey, give me your queries. That's the reality, right? You have your bosses, deadlines, things that are happening, the pressure that's coming. And you got to hit that deadline, so you start doing what you got to do. I mean, we've all been there. I've done it. I did it for this conference. I mean, you know, you just time. You got your job and everything else you got to do. And so you might start going around that API gateway. You might start talking directly to some databases. You know, you're just doing what you can. Part of that is they don't have the ownership and they don't understand what the value of necessarily that platform providing is. Now, in this full stack ownership, what you're really doing is you're creating those entities, those domains. Those are core shared resources that are being shared with people. Now, the chatbot team or the mobile team, the web team, whatever, they're creating essentially an experience API. That's their little subgraph, their little thing that does whatever they want. Maybe it's suggested products, right? And that's the experience they're building on because that's the little UI thing, the micro front end that that team owns. They don't want to have to worry about the product, how to integrate with the product, how to do all those things. But you saw how those entities join between that ID. That's how simple it is, right? Everything now works where you're still using your centralized security governance, everything that you've already implemented into your GraphQL API, now the team has ownership of that one little piece. I know a couple companies that already have architectures like this. It's very common when you have a mobile team and a web team where historically they had like separate API endpoints. Like the mobile team was like, yeah, we don't do some things the same as the web team, so we built our own API, but there ends up being common resources they end up using. So another flavor of this could be that whatever your graph router thing is, whether you're using, you know, Cosmos, you know, all the other, you know, things that are potentially out there, whatever you're using there, you might have the mobile team and the web team, they host their own version of that, and they pick and choose which services they use together. And maybe that router is more for internal common, like dashboards, support, admin portals, things like that. So more of my point here is when you start thinking about federation and how you're architecting and designing your schema out, try to meet closer to where your current architecture developers are. That's why I talk about this full stack pattern, because the team that owns their API, they see and perceive that part of their velocity is that they own their own little BFF and they can make changes to that. They can do things. They need that flexibility to keep creating those new rich experiences. So you've got to make sure you empower them to do that. And the architecture is there, right? Now, most people think of this architecture, right? Here's like the kind of common world where like, oh, we add a new subgraph. And it's very nice split where you have your front-end developers, you have your back-end developers. Just not everyone's already architected like that, right? These are different architectures of what we can do inside of here. And I think this is really important. Now, thinking a little bit about error handling, responsibilities inside of here, observability. That's the big differences inside of here. When you're giving ownership to a team where they own their little subgraph that's part of their full stack development, they also have to take ownership of those aspects. I commonly say when you're talking about errors, I like actually designing those errors into my schema. I think Sasha's talks on error handling have always been fantastic, and I agree with a lot of the discussion there. I think whenever it is a known behavior, your error, like unauthenticated is a good example, that's where you should be designing it into your graph, because you should be able to like give that. Sometimes, you know, the error that you're wanting to return, there's actually some suggestion or something that comes along with it that the clients can have, right? Like, oops, nothing was found. Did you mean this? That type of situation where that's a known expected behavior, not necessarily an error that nothing was found. So I like designing that stuff into my graph. But if you don't have ownership over those BFFs, you're now essentially taking on the role of like a support, right? So your platform now supports these client developers, and you're making all those decisions. So you now have to think of, for error handling, those type of situations. When you think of an error code, who's that error code actually for? What is the client developer going to do with that error code? If you can't give a good answer for that, then it should not be there, right? Extensions is definitely very common for handling errors and error codes and passing them through, especially between subgraphs. Most routers have some capabilities where you can intercept the traffic between subgraph requests when it's making the request of that query plan. And that's where a lot of the extension stuff can come along, and you can use those to handle kind of whatever your scenarios might be in there. Apollo Federation actually uses extension errors. So when you make composition errors, if you did like Rover Supergraph Compose with the JSON output, you'll see all of the extension errors, the location errors, and everything inside of there. So it kind of depends. Do you also want to have like location pointers and other things inside of there? It's definitely very helpful for subgraph developers, like the actual subgraph authors, having those errors pop up in its extensions. So it's very common for your production environment that no errors come out and show to anyone. Whenever there's an error, just return null. That's actually what we do at Apollo. If there's an error, you don't have authorization, anything like that, everything's just null. You just get null back. We don't want to give you any hints, information of like, oh, this was a validation error or something like that. Okay. I want to thank you all for coming along with me on all this. We are at the 10-minute mark inside of here. So I have a couple things I'm trying to decide right now what's the last thing we do. All right, one I just want to talk about real quick is Strappy as a headless CMS. Specifically because I think there's a lot of times you have maybe tooling or services that you're using that auto-generate something. So the way the Strappy CMS works is you create these like type content objects in Strappy, and then for each object you create, you essentially get an API endpoint for that object, and it gets exposed with an ID route field. So in our scenario, all of our pricing information was in Stripe, but our product CMS information like images and everything is in Strappy. And so we were going to design out the schema. I wanted to just kind of show it to kind of connect those pieces together. You can see I didn't put entities in here because I was expecting to do all this monolith. But more of the important point here is what I really wanted to highlight was this mutation pattern inside of here. So remember how I said I like to group things, namespace things? With the product ID product, it's kind of obvious, what are all the things with product? I kind of think of it as what are all the things I can do with maybe that entity. We do this on our platform API at Apollo. But for example, on the type mutation, you see we have product and we have a product mutation type being returned. That essentially encapsulates all of the what can I do with a product inside of there. And what that means is when I go in as a client developer to write a query, or a mutation, I'm writing like, mutation, product, and then it's now what are all the things I can do in there. And notice I put add image, for example. I didn't just put, something that's like a CRUD, right? Sure, there are things where you do have CRUD objects, like there probably is like an update product here, and you have aspects around that. But when you think about like what are the things you actually do with that entity, have it encapsulated in here. For like GraphOS and like what we have like a graph, and it could be like create variant because you want to create a new variation of that graph. So that's encapsulating that functionality in a nice little mutation. I call it nested mutations. I don't think it has like an official name. It's just a pattern I like. One important note though, because the product mutation is a type and isn't on the root mutation field, two mutations sent together will not run serially. They will run in parallel. This should never be a problem because you should never run two mutations in the same request. I will get on my high horse all day about this. I know there's some people that disagree, but if you are running two mutations in the same request, you should make a new mutation field that does both of those things together. Because otherwise you have to handle things like what happens if the first one passes and the second one fails. What do? You got to make decisions, and then you're going to try and expect the GraphQL spec to like solve that for you. Like that's not going to happen. It's going to take a while if you think that's going to happen. So that's one thing to note in here. Very specifically about that, in the GraphQL spec, the mutation type is a special type where all fields selected in the mutation type run serially. Meaning if there was an update product and I did add image and then update product, the add image field would run first and then the update product field would run next. If I put that all together in the product mutation and selected both those fields, they would run at the same time. If you have any questions about that, I know we don't have too much time. That's a little more of an advanced topic. Feel free to come to me after the class and we can talk more about it. But I'm a big fan of this pattern. Okay. All right. So let's quickly just wrap up with the last couple minutes we have. So what did we learn today? First, we started out writing an ideal operation, getting that feeling of like, all right, what's it like to be a new developer? And then we collaborated on it, came to an agreement. Then we looked at some REST API stuff, how to put those together, how to think about entities into those domains, and wrapping that up. We also talked a little bit about that ideal experience. I showed Rover, the CLI. I showed using Apollo Server for mocking. I really would challenge you all if you have different language servers, things like that. I think this is something we can do a better job sharing in the community of, what are our little mocking scenarios here and everything, because I think it makes it each developer a lot more effective in helping collaborate on these schemas and everything. We also talked a little bit about the architectures inside of here. I think those are really important in how we're designing our schema. And we talked a little about these questions. Now, I do want to touch back on these, a couple things about the common mistakes. So we did talk a little bit about like the REST API and some of those aspects. One of the common mistakes I didn't cover too much was CRUD. Let's talk about CRUD for a second, because I think it's really, really important. When we're designing out our GraphQL API, no matter where you are, and if you don't have this, gosh, I want to work at your company, you're very lucky, you're going to have some people that are naysayers to GraphQL. And they're going to talk about all the great things they can do in REST, and they're going to show you the great things they can do in REST. And you're going to build your GraphQL API, and you're going to show the great things that GraphQL API can do. But if your GraphQL API has looking cruddy, when they first look at that schema, they're out. Like you just immediately lost their attention in the discussion of like, should we adopt GraphQL? So when you're building out your GraphQL API and you have a REST API that you're looking at of like what we had there, it's very easy to get in the pattern of like, products, prices, and you start adding in all of these capabilities that ends up looking like, okay, here's the read capabilities, here the update capabilities, here's the create capabilities. That's one reason why I like that nested mutation pattern, because now it encapsulates what are all the things you could do with the product, and that's not something the REST team can show or do or have. So it's just one of the subtle details that shows the value of what GraphQL really brings, this expressive nature of what we can bring into our schema, right? And when I think of how I'm designing my graph, I really think your graph is your digital representation of your business, of your product. When people talk about like have an API strategy, a platform API strategy, what they're really getting at is how can we make our APIs in a way that every use case, everyone can take advantage of it. And once that gets figured out, that everyone that could use it could be others, like partners, external things, which become new revenue sources and all of that, right? You think of the companies that went from a consumer thing into turning it into, a product for other businesses. That's really where a lot of money can be made. I think Yelp's a good example. If you look at their business GraphQL API, excuse me. VS Code. Does this happen to everyone all the time? I feel like VS Code always has to update now. I love VS Code, but don't get too Microsoft-y. Okay, now, let's see, the questions, last ones. Time-based graph, I do want to touch on that. So, we saw entities in a structure of ID. One of the things that is also very important and this is with federation, is the concept of compound keys. So when you think of what is an entity, it's really a representation of an object uniquely identifiable by a certain thing. In a time-based graph, I would say that's the time. So like one common thing that a lot of people have is a location. And I've had people say like, you know, what should I do with this, you know? And really what they kind of get at with like the location is, you know, the way they find that spot is typically through a very singular thing, which is a latitude, longitude. And it's really weird to think about, but your location actually becomes a entity based off of that. So a compound key could look just like, you know, lat long, meaning I can uniquely identify a location if you give me the latitude, longitude. And very specifically, one of the changes that happened from Federation 1 to Federation 2 was really around the basic concept of ownership in an entity. In Federation 1, the subgraph that defined the entity owned it. And this was challenging for businesses that already had existing SLAs rules where they're like, well, yeah, but like not everyone has the same concept of a product, right? That team over there, they care about product from a SKU standpoint. That team over there from the product, they care about it from an order standpoint because it's shipping. So it's more of the representation of that entity slightly changes depending on where you are in the organization, and the key fields that identify that entity to that part of the organization change. So in Federation 2, entities can be represented in the way the subgraph can represent them, meaning you can define product by a key field ID in one, and then you can have it as a different key field in another subgraph, and that's totally fine. So when you start thinking about your time-based graph, I would say actually that timestamp is your entity definition in there, and now we're really talking about paginating through those entities. That would be the way I'd explore it. Now, that's a very, very gross simplification of like, oh yeah, just paginate through the time-based series inside of there. But that's probably how I would start to explore that of like, what's it look like to say the millisecond timestamp is actually now the key identifier, right? And now what's it look like for a time-based series pagination over that? And then start looking deeper into that. Now that is a federation-based concept inside of there, but that's how I would maybe start thinking about that.
I think the interesting part of that is like it basically mess up the caching that you guys do. Because like if you can think like your product and price, you offer them like a history time to correlate, it doesn't change every millisecond.
Right.
So it has a pretty wide range to
Yeah.
cache, but the current caching limitation is based on the key.
Yeah.
Yeah. So I think that is basically the trade-off that we have to make at the moment.
Yeah.
That's how I kind of like want to hear your opinion, like just from the first heard of the problem. What is your intuition? Yeah.
Yeah.
I'm glad you mentioned the combined key.
Yeah. It's actually most of the scenarios we all have in our applications. That's actually the case for most of our data, is that once the data gets put in, it actually doesn't change that often. Major League Soccer, I worked with them back in like 2018, and they had like a 98% cache rate, because once a soccer game's event happened, you know, someone kicked the ball and made a goal, it doesn't change. Like it's done, it happened. It's a timestamp, like it's never gonna change. So 100% cache rate on that, so for sure. Okay, I would love to be able to touch more on the redirect to another resource. At overrides in Federation is the way to do that. I forget who asked that question. If you want, we can chat a little bit after. We are just about at time. 10:30 on the dot just happened. I want to thank you all, everyone, so interactive. Y'all did so great. Give yourselves a round of applause. On the last day of the conference, I am blown away. You all did fantastic. If there's anything I can ever do to help, please let me know. You know, there really isn't any materials because it's really us having this interaction experience together. If you do want to have this, I am going to put this up as an Odyssey course, a tutorial with Apollo that I'll share out with everyone who registered for this list. Awesome. Thank you so much, everyone. Enjoy the rest of the conference.